Okay, the mission was to build a payload to take up on a weather balloon. And what we did, we were introduced to the project, and then we talked about what the scientists do. We talked about the engineering design, and then we talked about building the payload and what is involved in it, and then we actually built the outer casing, which is made of foam.
So what we did when we were doing our data collection, we had an Arduino, which an Arduino is basically like a little mini computer that we were able to program.
Yeah, what we're doing here is we're taking the Arduino microcontroller, we're connecting it to a PC, uploading the code that will flash an LED, and this is to demonstrate the capability of the Arduino to be programmed and to do a certain function. Eventually we'll be reading in sensor array into the Arduino and using it as part of a balloon package.
Once we learned how circuits work and to be able to get the board work, we were able to plug in our other instruments that were going to be able to be powered when they went up to the payload.
We had 3 different missions. One was just for ground mapping, where you just get the GPS and you get an aerial view to make your own aerial map, and then one was for weather, and then the other one was for carbon dioxide.
The pressure in the bottle is usually around 2,500 psi. And so you have to have a pressure regulator to bring that down.
You want to make sure you have a tarp or something so it's not touching the grass, because it could damage the surface of the balloon if it's touching the grass. You also want to be wearing gloves like nitrile or latex gloves, because the oils from your hands will get on the balloon and it'll create, a film on the balloon that's easier to pop than the rest of it, so it'll pop earlier.
So we connected our payloads, we tethered them to the balloon, let them go, and it was lifted up to over 100 feet. The first payload went well. The second one, it became a little windy and it was kind of blowing all over, so we had to make a few more adjustments. Once we got about 4 or 5 minutes worth of data, we pulled it down, brought them back into the building, removed our SD cards, and dumped our data into the computer so we could analyze it.
We also included a GoPro camera into our payload. So on the bottom of our payload, we cut out a hole, and as the payload lifted, it was taking pictures of the ground every 10 seconds. We were getting data readings every 2 seconds. So all we had to do was match up our data readings from our GPS to the pictures that we took as they rose and as it went up. The Arduino itself, we were able to take information, and we had latitude and longitude readings, we had altitude readings, we had speed readings, and basically what we did is we just took the data and we graphed it and we compared it to the pictures that we had. We were able to actually see a map of where the payload actually went, and the distance and the height and things like that.
This workshop was amazing because we got to not only get real data and analyze real data, but it introduced all kinds of topics that you teach in the classroom. You could use it for coding, you could use it for building circuits, you could use it in earth science for looking at different variables. You could use it in math to look at relationships between all kinds of variables. So it's so applicable to the classroom, but at the same time a lot of fun.